We are studying chapter number 5, heat in science 1. I think we have had one session of this in which we looked at the basic concepts and we started studying the chapter. We will continue with that, and today's focus will be on the anomalous behavior of water. This is what we have studied in the last session for this chapter. We studied what heat is, what temperature is, how they are similar and how they are different from each other. What are the units of measurement for heat and temperature? That was the prerequisite. Then for this year, for the current chapter, we started with the concept of latent heat. We studied what latent heat is, how do we see it in real life. We also studied the concept of specific latent heat to make latent heat comparable from one substance to another substance. And we finished the last session, by looking at some strange examples of ice ball, बर्फ का गोला जो हम खाते हैं वो कैसे बनता है and क्यों होता है वैसा. We also briefly looked at a situation where we are able to cut and join a block of ice just with a metal wire, nothing more. This is what we have studied. So let us see if we remember and if we have understood. First question. There is a simple table. It has 3 columns. First column is of quantity. Second column is of energy. Third column is unit of measurement. Do the matching and share the matching with me in the chat. First, write it in your notebooks. Write the question, write the correct answer in the notebooks. Look at the screen for the correct answer. I am showing it to you by drawing a line, but that is not how we will write. When such matching question comes, we have to redraw the table, rewrite the table with in the correct order. So heat, remember, heat is a measure of both the total energy, so both potential and kinetic energy. And heat is measured in joules. So heat, P plus Ke, 10 joules. Temperature, on the other hand, does not measure potential energy. It only measures the kinetic energy, and it is measured in Celsius. So 10 Celsius or Celsius, I should have written, would have been much better. This is the correct matching. Fill in the blanks. And once again, you draw this table, you write this table in your notebook, and then share the answer with me in the chat. Don't look at the textbook. Don't look at the guide. See if you can complete this table from your memory. All we have to do is we have to write the melting point, boiling point, specific latent heat of fusion in calories, and specific latent heat of vaporization in calories per gram. Those numbers, those values. Write it in your notebook, then share it with me in Zoom chat. Remember that we need to remember these things. So melting point will be 100 degrees Celsius. Boiling point will be 0 degrees Celsius. Latent heat of fusion will be 80 calories per grams. 80 calories per gram. And latent heat of vaporization will be 540 calories per gram. These 4 numbers we will have to remember for a good performance in tests. Thank you. So sir wrote wrong. Melting point is not 100. Melting point should be 0. Correct. Boiling point should be 100. So at least Chand is awake. Thank you. Melting point is the temperature at which ice solid transforms into liquid. For water, ice, it is 0 degrees Celsius. Boiling point is the point where the liquid transforms into gas. For water, it is 100 degrees Celsius. Once again, there is a table, but this is not about matching. We have to fill in the blanks. So on the left-hand side of the table, there are two columns in the table. Left-hand side, the change of state. What is the change in the state of matter that is given? So solid to liquid, liquid to gas, gas to liquid, liquid to solid. These things are given. On the right-hand side, we have to write whether what happens with the latent heat in each of these cases. That is the latent heat absorbed or the latent heat released? Once again, complete this table in your notebooks and then share it with me in the Zoom chat. For this, if you want, you can refer to the textbook. You should be able to find the answers if you want on page number 63. Always remember that most of the times the effect of heat can be measured using temperature. When we heat something, its temperature will rise, but not always, because heat has two effects. Heat can change the temperature by changing the kinetic energy. Heat can also change the state by changing the potential energy, by weakening the bonds or by strengthening the bonds. So when the state is changing from solid to liquid, latent heat is absorbed. Same thing happens when the state is changing from liquid to gas. But the ulta, the opposite happens when the state of the matter changes from gas to liquid. Heat is released. Also, when the state changes from liquid to solid, heat is released. Another way the same thing released is mentioned in our textbook is given off. No? छूट गया, उससे निकल गया, उसने दे दिया, released. These are the correct answers. Today, we will focus on anomalous behavior of water. In the last class, you referred to the dictionary and you figured out that anomalous means not normal, abnormal. Anomalous also means something wrong or problematic. Okay? In this case of water, it only means abnormal, not normal. But to understand what is not normal, we should also know what is normal. Okay? So pay attention. This is very important. This has implications in a real life situation, and there is a very counterintuitive theory behind that. So pay attention. What we already studied, we looked at in some detail is how ice ka gola is made, baraf ka gola, जो कि हम बड़े चाव से खाते हैं, and also how we can cut and fuse a ice block. To remind you, we discussed to make a ice ka gola, baraf ka gola, we first break the ice or grate the ice, shred the ice, हम उसके टुकड़े टुकड़े करते हैं. Then we take a stick, we take the ice in our hand or some way and we lump it around the stick. So we start with ice, we breaking it, we are lumping it around the stick. जैसे हम छोड़ते हैं वो जुड़ जाता है. Very interestingly, हमने सबने खाया है, लेकिन हमने कभी ये सोचा नहीं कि ये कैसे जुड़ा. And then we also looked at another situation where कि हमारे पास एक बर्फ का बड़ा ब्लॉक है. जनरली ये ऐसे ब्लॉक हम अपने नॉर्मल लाइफ में देखते हैं. When there is a party or something and lot of ice is required, you would have seen ice blocks being used. So again, to cut it or to break it, ज़्यादा मेहनत की ज़रूरत नहीं है. All we can do is apply some pressure using a wire, and it will cut through the block. And after it cuts through the block, if you don't remove the blocks, if you don't separate the blocks, if the blocks remain touching, then they will again join. Very interesting but strange happenings. And we said this phenomenon is called regulation. This phenomenon is called regulation. And we briefly said regulation is when what ice turns into water on application of pressure. And it converts back into ice when the pressure is released. We did not study or we did not discuss why that is happening. How is pressure impacting the state of the ice or water? That is what we are going to study. And this, I told you, I gave you a hint that it is because of the anomalous behavior of water. What is this behavior? Normally, generally, the density of solid, density means kitna tightly packed. You, all of you know this. Mainly three states of matter: solid, liquid, gas. In solid, the particles of the substance, the molecules are very close to each other. They are tightly packed. They have a definite shape and size. They have a definite volume. Everything has a definite volume, not gases though. But when they are heated, the molecules move apart, and that is why they still have the same volume, but they no longer have the same definite shape and size. They lose the shape and size. They start flowing liquid. This is applicable to most. So what is happening in the general case? General case where the density of the solid is more than density of the liquid. If we heat it, the distance between the molecules increase. So they expand. Volume also increases. Volume changes. Volume also increases. The shape and size, everything changes. But volume remains definite. It changes, but it remains definite. In case of gas, the volume is indefinite. अगर हम इतना सा गैस लेंगे और एक छोटे डब्बे में रखेंगे, then the volume of the gas is the volume of the dabba. If you take the same amount of gas and put it in a room, then now the gas spreads across the room. So volume of the gas is volume of the room. So gas, in case of gas, we don't have a specific volume. Na volume hai, na shape size hai. These are basic concepts. I'm sure you have studied earlier. Now, again, when we increase the temperature, the distance between the molecules increase. And so the volume increases, expanding. And because the volume increases, the density comes down. Gap बढ़ गया ना? Density comes down. Temperature and pressure have similar impact. क्यों? अगर हम प्रेशर डालेंगे, माने किसी चीज को हम दबाएंगे, तो सब चीजें पास पास आ जाएंगी. एक बॉल जो होता है, जो जिसमें जो प्लास्टिक रबर का बॉल होता है, हॉलो बॉल, व्हेन वी स्क्वीज इट बड़ा हो जाता है, व्हेन वी रिलीज इट बड़ा हो जाता है. और इफ यू टेक स्पंज, व्हेन वी स्क्वीज इट, its volume decreases. When we release it, the volume increases. Right? So mass remains same, but the volume changes by application of pressure also. माने प्रेशर जितना ज्यादा होगा, वॉल्यूम उतना कम होगा. वॉल्यूम कम होगा मतलब डेंसिटी ज्यादा होगा. जितना प्रेशर कम होगा, वॉल्यूम उतना ज्यादा होगा. एक्सपैंड कर रहा है. So the increase of temperature or the decrease of the pressure has the same effect, and the effect is expansion. Volume increases. Now, in the same general case, if you do the other thing, the opposite thing, that is, instead of increasing the temperature, if you decrease the temperature, of course, the opposite thing will happen. Instead of expanding, things will contract. That is, volume will decrease. That is, density will increase. Something similar will happen when we do the opposite of what we did for pressure also. So instead of decreasing the pressure, if we increase the pressure, then things will contract. Contraction means volume will decrease. It's the same mass, volume decreases. That means density goes up. In normal cases, where density of the solid is more than the density of the liquid, increase of temperature or decrease of pressure leads to expansion, increase of volume. decrease of temperature or increase of pressure leads to contraction, that is decrease of volume or increase of density. Having understood what happens in the general case, as we already know, we are studying the anomalous behavior of water, abnormal behavior of water. So the solid form of the water is called ice and the liquid form of water is called water. Water's behavior does not follow what we discussed just now. We discussed just now that increase of temperature or decrease of pressure causes expansion. That is not what happens with H2O. We discussed that when we decrease the temperature or increase the pressure, there is contraction, volume decreases, density increases. That doesn't happen with water. And it is not the case that H2O always is working against that general rule, that general observation. No. The behavior of water in a specific temperature range, that is between 0 degrees Celsius and 4 degrees Celsius, it is very strange. It is really very strange. So between 0 degrees Celsius and 4 degrees Celsius, when we are heating, what happens is the density of the ice is less than the density of the water. Ice is solid, right? Water is liquid. Generally, the density of the solid is more than the density of the water. But in this case, the density of the solid is less than the density of the water. Why does this happen? This happens because of the peculiar shape of the water molecule. उस water molecule का shape ही ऐसा है कि जब हम उसको solid करते हैं, वो solid तब बनता है जब lock हो जाता है. जरूरी नहीं है कि पास में है, जब lock हो जाता है. Because it is an angular molecule. You will study about it in much more detail later in college. For now, it is because of the shape of the molecule. So उसका consequence क्या हुआ? Ice, which is solid form of H2O, instead of sinking in water, it floats on water because it is less dense. We can't say it is lighter. No, it is less dense. For the same mass, the volume of the ice is more than the volume of the water. That is why its density is less. That is why it floats and not sink. Now, if this is the case, what is the case? Now the density of the solid is less than the density of the liquid. What will happen now if we increase the temperature? If we increase the temperature, definitely the solid will turn into liquid. That is going to happen. But this transformation will not result in expansion. It will result in contraction. Volume will decrease. Density will increase. If you decrease the pressure, then again, the complete opposite will happen. Opposite from the general case. In case of the general case, if you decrease the pressure, things expanded. But now, when we decrease the pressure, things will contract. If you decrease the temperature, or if you increase the pressure, things will expand, opposite to the general case. Now let us try to understand regulation in this context. In the context of the anomalous behavior of water. Let us take the case of barf ka gola, ice ball. We start from ice, we are shredding it. हमने उसको कस दिया या फिर तोड़ दिया, जो भी किया. We have smaller pieces of ice. We are picking up some ice in our hand and we are lumping it around the stick. Now, when we are lumping it around the stick, we are applying pressure. Pressure is increasing. In general, when we increase the pressure, the volume should decrease, but this is water. It does not behave in the normal way. it converts into water. Suddenly, it converts into water. And when we release, we are removing the pressure. In the normal case, things should have expanded. But now the ulta will happen. The water will convert into ice. And of course, it will be associated with some release and absorption of heat also. जब हम उसको दबा रहे हैं, it is getting the heat from our hand. It is also getting the pressure that we are applying. Because of this heat, because of this pressure, instead of the volume decreasing, which happens in the in the normal case, when we are pressurizing, the volume decreases, but in this case, the volume ulta happens. Think. If we use the same logic for the ice block which we are trying to cut. So when we take the metal wire and we are putting pressure on the ice, because this application of pressure, ice will get converted into water. Water is liquid, cut gaya. The wire will go down. Again, it will apply pressure on more ice, which is below that. Again, that ice will convert into water. The wire will go down, cutting the ice. And the moment the wire goes down, now the ice that is above that wire, it is not experiencing any pressure. Pressure is released. Because the pressure is released, but the temperature is still between 0 and 4. So it fuses. Water becomes ice once again. So we have this phenomenon of regulation because of the anomalous behavior of water in the temperature range 0 degrees Celsius to 4 degrees Celsius. When we study this behavior of water, when we try to study, because we are in science, nothing happens by feelings, nothing happens with opinions. In science, everything depends on facts, observation, experiments, and repeated experiments. So how was this phenomenon observed? Very simple. The same experiment that we did previously. We took some ice and we heated it. So what scientists did, even you and I can do this. We can take water or we can take ice in a beaker and we can heat. And while we are doing it, we have to measure both the volume and temperature. When we plot this volume on the y-axis and the temperature on the x-axis, we will see that from 0 degrees Celsius to 4 degrees Celsius, in normal cases, as the temperature increases, volume should also have increased. But in case of ice water, between 0 and 4 degrees Celsius, you see what is happening. Temperature is increasing. On the x-axis, temperature is increasing. But on the y-axis, volume is decreasing. Anomalous behavior of water. But beyond 4 degrees Celsius, as the temperature increases, the volume also increases. This is the normal behavior. This is the expected behavior. This is not anomalous. So anomalous is just between 0 degrees Celsius and 4 degrees Celsius. Between points A and B, from 0 degrees Celsius to 4 degrees Celsius, as the temperature increases, the volume decreases. That is the anomalous behavior. This part of the graph has a negative slope. Now let us see if we have really understood what is happening. Looking at the graph. Yes, Chan. Between 0 degrees to 4 degrees Celsius, if we supply more temperature, if we increase the temperature, then there is contraction. Correct. Because of that contraction, ice turns into water. Tell me, looking at this graph, if I ask you, at what temperature will water have the highest volume between 0 and 4? Between 0 and 4, 0 degrees Celsius and 4 degrees Celsius. At what temperature will the water have the highest volume or minimum volume, not max, highest volume? Akhilesh, your answer is correct. I've changed my question. Look at the question on the screen. I'm sorry, I asked you the wrong question. Between 0 degrees Celsius and 4 degrees Celsius, at what temperature will water have the minimum volume? सबसे कम वॉल्यूम होगा, नहीं सबसे ज्यादा कॉन्ट्रैक्ट कर गया होगा. It's very clearly written on the graph. At what temperature? Chand, you are looking at the wrong axis, beta. I'm asking you, at what temperature will water have the least volume? I'm not asking you about the volume. I'm asking you about the temperature. Akhilesh, Rajesh, try answer again. Yes, you have answered and it is correct. It will be at 4 degrees Celsius. At 4 degrees Celsius, it will have the minimum volume. देखो सबसे नीचे है ना line वहाँ पर. And because the mass remains same, but the volume has become minimum at this point, that means at the same point, that is at 4 degrees Celsius, the density is highest. Remember this. So in addition to 0 degrees Celsius, at which is the melting point, in addition to 100 degrees Celsius, which is the boiling point, another very important temperature with respect to H2O is 4 degrees Celsius. Minimum volume, highest density. Question number 2 in the exercise refers to the same graph, and you have been asked some questions. It says, observe the following graph, considering graph. So observe, dekho, samjho. Considering the change in volume of water as its temperature is raised from 0 degrees Celsius, discuss the difference in the behavior of water and other substances. Now, so we are comparing and contrasting water with other substances from 0 degrees to 0 degrees and above. That is one part. And then the second question is, what is this behavior of water called? Quickly answer in the chat box. What is this behavior of water called? We have been referring to this word from the last session. What is this word? Anomalous behavior of water. Very good. Keep your spellings correct. It is A-N-O-M-A-L-O-U-S, not M-O-M-A. Check again and again in your dictionaries. Is it N-O-M-O or M-A? Be careful about the spellings. Okay? That you have answered correctly. Very well done. Now what you are going to do is, you are going to compare and contrast of the behavior of water between 0 degrees and 4 degrees Celsius. Not entirely. No, not 0 and 4. From 0 degrees Celsius, what happens to the water? What is the behavior of water from 0 degrees Celsius when we start heating it? Write it in the notebook. You are doing the compare and contrast. Take a picture, send it to me on WhatsApp. We should write the answer to this question in this way. We should make 2 points, and the 2 points should refer to 2 specific temperature ranges. Thank you, Khadija. First point would be from 0 degrees Celsius to 4 degrees Celsius. Then the second point will be more than 4 degrees Celsius. Under the first point, 0 degrees Celsius to 4 degrees Celsius, you will say, as the temperature increases, the volume decreases. And this is not what happens in other substances. This happens only in case of water. Beyond 4 degrees Celsius, When we increase the temperature, the volume also increases. This is exactly same as what happens with other substances. So for other substances, whatever may be the temperature, whatever may be the temperature range, as the temperature increases, volume also increases, right? But in case of water, between 0 and 2 degrees Celsius, volume decreases with increase of temperature. Beyond 4 degrees Celsius, volume increases with increase of temperature. Structure your answer in these 2 points. Next is an experiment with respect using Hope's apparatus. Hope is the name of the scientist who designed this apparatus, and this is again to study the behavior of water with respect to temperature, volume, all these things. It's a very simple apparatus. Apparatus is an equipment. It has a cylindrical body. It's a long beaker, and it has a plate kind of thing, a container kind of thing around that cylinder. And it has 2 points where thermometers can be inserted into the cylindrical beaker to measure the temperature. Kiska temperature? We are taking water in the cylinder, normal water. And we are taking a freezing mixture, usko thanda karne ke liye, bahut thanda rakhne ke liye, we are taking a freezing mixture. This freezing mixture is usually a combination of some ice and salt. Freezing mixture. So what we do then is we measure the temperature of the top portion T2, and we measure the temperature at the bottom portion, and we are calling it T1. And we measure it every 15 seconds, every 30 seconds. And once again, we plot them in a line graph. In the line graph, usually on the x-axis, we have the time. Here also we have the time. And on the y-axis, we have the temperature. We are measuring 2 temperatures, T1 and T2. So we have 2 lines, T1 and T2. So this line T1 shows how the temperature that is measured by the bottom thermometer changes. This line T2 shows us how the temperature which is measured by the upper thermometer changes. Very interesting shapes, no straight lines. Now we have curves, and not just curves, so different curves. First, you see in the top portion, they are going away from each other. And then at a point, they cross each other. Then T2, the line corresponding to T2, now is below T1. What exactly is happening? Just by looking at the graph, it is very clear that between this, say, 12 degrees Celsius and 4 degrees Celsius, pani humne liya tha 12 degrees Celsius. And we are freezing it. So the temperature is decreasing. As the time increases, temperature is decreasing. So both the lines have negative slopes, 100% negative slopes. But the slopes are different. Very clearly, the temperature T1 is reducing much faster than the temperature T2. T2 बहुत धीरे-धीरे कम हो रहा है. T1 बहुत जल्दी-जल्दी कम हो रहा है. क्यों हुआ ऐसा? पता करेंगे. At 4 degrees Celsius, it changes. At 4 degrees Celsius, T2 जल्दी ठंडा हो जाता है. And T1 वो ठंडा होता है, लेकिन और slowly ठंडा होता है. So why is this happening? Why don't we get straight lines? Why are the 2 lines intersecting each other? This is again because of the anomalous behavior of water. Right? Remember, 4 degrees Celsius is an important temperature. 0 to 4, the behavior of the water is anomalous. Beyond 4, it is normal. So, see what is happening. We are not keeping the freezing mixture at the top, or we are not keeping it at the bottom. We are keeping it somewhere in between. So because of this freezing mixture, the water around it gets cold. So from 12, it is cooling down. When it is cooling down, because it is beyond 4 degrees Celsius, the behavior of the water is not anomalous. It is normal. That means it is becoming denser. Because it is becoming denser, वो नीचे जाता है. नीचे कहाँ है? यहाँ नीचे की तरफ T1 के पास. So the water at the top, not at the top, in the middle part where we have the freezing mixture, it is getting cooled. That it is still above 4 degrees Celsius. So its density increases. So it goes down. When it goes down, more and more water below gets colder. So T1 becomes colder much faster. While this is happening, the hotter water, the warmer water is going up. So although the overall temperature is going down for T2 also, but the reduction of temperature is much slower. Now at 4 degrees Celsius, we are not stopping the freezing. We are still continuing to make the water colder. So while we continue the cooling of water, now in this range from 4 to 0 or 0 to 4, the behavior of the water is anomalous. From 0 to 4, in the previous theory, we understood when we are heating the water from 0 to 4, its volume decreases, its density increases. But when we are cooling the water from 4 to 0, the opposite thing will happen. Instead of the volume increase, instead of volume decreasing, the volume will increase, the density will decrease. And because the density is now decreasing, अब जो पानी ठंडा हुआ, now it will go up. It will not go down anymore. From 0 to 4, the colder water will go down. From 4 to 0, the colder water will go up because now the density is decreased. And because the colder water is going up, the hotter water will come down. So although both the thermometers will show decrease in temperature, but now because more and more colder water is going up, the reduction in the temperature measured in T2 will be much faster than the reduction in the temperature that will be measured by the thermometer T1. That is why the lines intersect. And T2 becomes 0 much faster, much earlier than T1. Why is this anomalous behavior of water important? Why are we studying? Very interesting situation. There are many more reasons, there are many more applications, or there are many more instances of the anomalous behavior of water. For example, when we discuss the ice ka gola and when we discuss the cutting of ice, all those are instances or consequences of anomalous behavior of water. But of much bigger impact for all of us are these three things. Aquatic life. Aquatic life means life that exists in water, in lakes, in ponds. Suppose, and you know this from geography, that there are places in the world which are colder, and there are very cold, and there are places on this planet which are hotter. Places nearer the poles, they are colder. Places nearer the equator, they are hotter. So some countries, the temperature, average temperature is much colder than average temperature of India. And during winter season, they have below 0 degrees Celsius temperature. Now suppose we take a glass of water and keep it on our table at such places. What will happen to that glass? Will it not freeze? It will. Now imagine a pond, a lake. The temperature is much below 0 degrees Celsius. It is -17, -30 degrees Celsius. फिर तो पूरा पानी जम जाएगा. And if the water freezes, all the organisms that are there in that pond or lake, they will die. Where will they go? They are aquatic animals, but they don't die. And the reason is the anomalous behavior of water. Because as the water in the pond or the lake, it starts freezing, its density decreases instead of increasing. Because the density decreases, it starts coming up, it floats. So the top of the river, the top of the lake, the top of the pond freezes, and it stops, it insulates the bottom of the lake. from freezing. The bottom of the lake, the bottom of the pond remains liquid. The organisms can still be alive. They don't die. आपने कभी कभी देखा होगा शायद डिस्कवरी या नेशनल जियोग्राफिक चैनल में that in the colder places they dig a hole in the river. The lake is frozen, but then they cut a hole and then they are fishing. This is called ice fishing. अंदर में पानी है, ऊपर ऊपर बर्फ. So this is good. This is good, but it is not good all the time. It is not good. In the same cold countries, they also need water for domestic use, right? And water is supplied to our homes through pipes. Water is required in winter also. Now water is being supplied in the pipe, and suddenly it is very cold. The water freezes. Water freezes, so the density decreases, volume increases. मतलब जो पानी उस पाइप से जा सकता था, now instead of the water we have ice. It will take more space. और हमने नल बंद किया हुआ है, तो पानी जमा है, पाइप में भरा हुआ है, and it is freezing. It is expanding. The pipes burst. पाइप फट जाता है. It's a problem with the water supply. So they have to design their water supply in a different way so that the water does not freeze. It's not good. And the third thing, all of us have learned this in geography, erosion. One way erosion happens is during the monsoons, during the rainy season, the water gets into the cracks in the stones. When it becomes cold, the water freezes. When it is freezing, its density decreases, its volume increases. So this expansion of the water inside the stones, rocks, it causes the rocks to break. And this continuous breaking is called erosion. This also leads to formation of soil. It's a necessary process. So when it happens naturally, it is good. But if the same erosion happens on our roads, तो क्या होगा? बारिश हुई, temperature change हुआ, हमारा road टूट जाएगा. That is why we have so many potholes. We don't construct them properly. Good for aquatic life, bad for pipes, and bad for erosion. There are two very simple questions related to this. Question number 6, part A. What is the role of anomalous behavior of water in preserving aquatic life in regions of cold climate? Now you can answer. Another question is, in cold regions in winter, rocks crack due to anomalous expansion of water. Same thing. Whether it is a lake or a pond which has aquatic life, or it is a pipe, water pipe, or a rock. If it has water, if it is cooled between 4 and 0, its density will decrease, its volume will increase, it will become ice. It is good in a way because then the ice will float to the top and the life will not be killed, but it is not good for the rocks, it is not good for the pipes because they will break. And that is what you will complete as homework. You will complete the notes. So the notes will be about anomalous behavior of water, and the notes will not be complete because we will study about the effect on melting and boiling points effect on melting point and boiling point due to this anomalous behavior of water in the next class. But you can definitely answer these questions that we discussed in the class today from exercise question number 2, 6A and 6C. Complete and share it with me by tomorrow night.